Hello everyone. So now we are going to solve our assignment 1. So there are 15 questions. Let me show you the question first. This is the first one, second, third, fourth. You can solve this question. You can pause the video and solve this question. Okay. And then match your answers. This, then this, then this, then this question, this question, this question, this question. This was gate 2022 question. This was also asked in gate. This was also asked in gate. Okay. These questions you can solve. Let's start with the first one. Okay, so assuming diodes to be ideal, you have to find the value of V and I. Okay, so tell me what we will do. You can apply any test you want. I prefer open circuit test. Okay, I personally prefer open circuit test. You can apply short circuit test as well. So I will apply open circuit test. So here I am having zero voltage, and here I am having. If I am applying open circuit test, that means this is open circuit. This is open circuit. There is no current in any branch. There is no current. This is open circuit. This is open circuit. This will also be open circuited. So here I am having minus 10. So basically I am having 10 volts here, right? Across this diode I am having 10 volts, and across this diode 10 here and minus 10 here. So that means here I am having 20 volts. That means both diodes have the capability of turning on, but first D2 will be on, right? So first D2 will be on. Five kilo ohm, 10 kilo ohm, and 10 volt. Okay, now we will find this potential. We have to find the potential here because we need to check if D2 is on or off, right? This potential is 0. So now we will find the potential here. Now I have told you one method, right? I will be using this again and again in analog electronics. Okay, everywhere. If there is potential V1 here, potential V2 here, what will be this potential? This potential V will be V1 R2 plus V2 R1 upon R1 plus R2. Right? In network analysis, we studied it. Right? So again and again, I will be using in this analog electronics subject. Okay, so I'll be using this everywhere, so you should remember it. So what will be the potential here? The potential here would be 10 into 5, 50 minus 10 into 10 minus 100 by 15. 50 minus 100 by 15. Potential of this one into this resistor, minus 10 into 10 minus 100. 10 into 5, 50 upon total resistance, 15. So this is some negative value, right? This is minus 15, minus 50 by 15. So here you are having minus 50 by 15, and here you are having 0. That means even diode D1 is also on. D1 is also on. Okay. So diode D1 is also on and D2 is also on. Both D1 and D2 are on. Okay. So now what you can do? This is a 10 volt battery. This is the resistance. Diode D2 is on. This is the resistance. And this is grounded here. Right? Both diodes are on. And this is your potential V. This is your 10 volt battery. This is 10 kilo ohm. And this is minus 10 kilo ohm, minus 10 volt, and this is 5 kilo ohm. So tell me, what is the current here in this direction? The current here is, this is 0, this is minus 10. So 0 minus 10, basically the current here is 2 milliampere. 10 by 5, 2 milliampere. And here what is the current? 1 milliampere. Right? Here the current is 1 milliampere. And this 0, this is 0, so this will also be 0. So value of V is 0 volt. And what did they ask? The value of current I. Okay. So here I am having 1 milliampere current and 2 milliampere current is there. That means 1 milliampere current would be coming from this side. Right? So value of I is 1 ampere milliampere. This is simple and network analysis problem, nothing else. Okay. We short circuited this, we short circuited this. So 0 volt here, 0 volt here, that means 2 milliampere current here. 0 volt here, 0 volt here, that means 1 milliampere current. 1 milliampere, 2 milliampere, that means 1 milliampere current would be coming from this side. So current I is 1 milliampere and voltage V is 0 volt. This voltage V is calculated from the ground. So you have to start from ground. From 0 you started and went to 0 only. So this is 0 volt only. Okay. So V is 0 volt, current is 1 milliampere. Let's solve this question. You have to find the value of V and I. So what will happen? Diode will be off. Diode will be off. So tell me what will be the value of V? 5 volt, right? Because diode is off. So this is the condition, right? This is the condition. This is 2.5 kilo ohm. This is 5 volt and diode is off. Current is 0. So current I is 0. What is the potential? This is the potential V. And potential V is 5 volt. Right? Now current is flowing and potential V is 5 volt because the current in the resistance is 0. That means V will be equals to 5 volt only. Because this 5 volt will come downward. Okay. Now what about this? Here, what will be the condition of diode? Diode will be on here because this is 0 and this is minus 5. Here if you apply open circuit test, this is 0, this will be minus 5. At this potential you will be having minus 5 if you apply open circuit test here. Right? So this will be on minus 5. So diode will be on. Okay. So diode is on. This is your minus 5 volt. This is your 2.5 kilo ohm. And this potential they are referring to. If this is ground, look, if this is ground, this potential is going to be minus V, right? And since minus V is equals to 0, V will also be equals to 0. And what is the value of current? From this is 0 potential, this is minus 5 potential. That means the current is flowing from here to here, that is 2 milliampere. Okay, so the current that is flowing is 2 milliampere and V is equals to 0 volt. Are you getting how I am writing the potential? Look, this is short circuited because diode is on. Okay, diode is on. Diode on. Diode is on, so this is getting short circuited. Okay, that means 0 minus V. This potential is minus V. And minus V is equals to 0 only. This will be completely grounded. So potential V is 0 only. But what is the potential V? If this is 0, this potential is going to be minus V. From 0 to minus V. This potential is going to be minus V. Since minus V is equals to 0 only, so V is equals to 0 volt only. Are you getting my point? Let's move on to next question. These kind of question we have already solved, right? In the concept only, right? So tell me which diode will turn on first. Open circuit test you will apply. Okay, this will be 0. This will also be 0. This will also be 0. So which diode will turn on first? 10 volt will turn on first. If 10 volt turns on, that means 9.3 will be here. That means this will be off. This will be off. Are you getting my point? I am applying short circuit test, open circuit test. If I applied open circuit test, this diode will have the maximum forward voltage drop. That means it is having 10 volt forward voltage drop. That means here I will be having a battery of 0.7. That means I will have 9.3 here, then 9.3 here, and 9.3 here. Since 9.3, this will be off, this will be off, and this will be on. Right? Okay. So what is the condition? 10 volt. V gamma is 0.7. So 0.7, 10 volt, 0.7, and 9.3 kilo ohm. Right? And this is the potential V, and this is the current I. Potential V is 9.3 by 9.3 K. So basically, sorry, potential V is 9.3 volt only. Okay, and the current I is 9.3 by 9.3, that means 1 milliampere. Well and good, easy question. Let's move on to the next problem. Tell me what will be the case in this scenario. Apply open circuit test. Okay, if you apply open circuit test, this 5 will come downward because there will be no current in this branch, because this will be open circuited, so there will be no current in this branch. So this 5 will come downward. This will be 5, this will be 5, and this will also be 5. Now this has a forward voltage drop of 4 volt. This has a forward voltage drop of 2 volt, and this has a forward voltage drop of 1 volt. So which will turn on first? The lower one will turn on first, right? This one first turns on. So the lower one turns on at first. So if this turns on, that means 1 volt will come here. So this 5 volt will be replaced by 1 volt. This 5 volt will be replaced by 1 volt. So this is 4 volt and this is 1 volt. That means this will be turned off. This will also be turned off, and only this will turn on. Are you getting my point? How did I solve it? 4 volt is there, 3 volt is there, 1 volt is there, and from upward 5 volt will come. So the lower one diode is having 4 volt, above that 2 volt, and above that 1 volt. So which one is having the maximum? The lower one. So it will be replaced with the short circuit. So 1 volt will come. So here 1 volt will come, right? And this 1 volt will carry upward. So here you are having 1 volt, and here you are also having 1 volt. So this will also be off, and this will also be off, because here you are having 3 and here you are having 1. So that means this will be off and this will also be off. So what will be your V? So simply this will be your circuit. Only the lower diode is on. Okay, the one having the 1 volt, and this is your 4 kilo ohm, and this is your 5 volt, and this is your V. This is current I. So V is your 1 volt and current I is 1 milliampere, right? Current I is 1 milliampere. How it is 1 milliampere? 5 minus 1, that means 4 by 4 kilo ohm, that means 1 milliampere. Got my point? Well and good. Let's move on to the next problem. This is a very good problem. I want you to try it on your own. Okay, try it on your own. What I will do, I will apply open circuit test, or you can apply short circuit test as well. No, you can't apply short circuit test. If you apply short circuit test, what will happen? All these will be turning on. So this will say I will have 15 volt, this will say I will have 10 volt, this will say I will have 5 volt. So you can't apply short circuit test here. Okay, so you have to apply open circuit test only. 2 kilo ohm. This is 12 volt. This is 1 kilo ohm. This is here 6 volt. This is 3 kilo ohm. Here you are having 15 volt. Here you are having 10 volt, and here you are having 5 volt, right? Now what is the scene? Is there any current? Is there any current? All current are 0, right? Do you know the potential of this point, 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 this point? Do you know the potential of these 5 points? Can you say it is 0? You can't say, because this is open-ended. None of the point is connected to ground. These are open-ended. You don't know what is the potential. So you have to consider some potential. Let's just assume if this is having V potential, the same potential will go here, the same potential will go here. Now there is no current in these branches, 0 ampere, 0 ampere, 0 ampere. So this same potential will be varying here. Now you have to compare. Now what you can think, you can take any value of V. Let V is equals to 1 volt. So what will happen? This diode is having 14 volt voltage drop. This diode is having 10 volt voltage drop. And this diode is having 4 volt voltage drop. So which will turn on first? This will turn on, right? This will turn on. And if this turns on, that means 15 will come here, this will be off. And this 15 will also come here, this will be off. So these two will be off. Are you getting my point? I am solving this side of circuit. Okay, I am considering some potential. Let's just assume this potential is 1. 15 minus 1, 14 volt drop here, 9 volt drop here, and 4 volt drop here. Okay, why it is 10? It is 9. Okay, 9 volt drop here and 4 volt drop here. So 14 is the max. That means this will turn on. That means this 15 will come now. That will turn off the 10 volt diode, and that will turn off the 5 volt diode. Okay, so only at this side only this one is on, and rest are off. Okay, let's see here. Okay. Yeah. So this 15 comes here, this 15 will go here as well, right? This 15 will go here as well. Now which one it will turn on first? Both have the capability of turning on, right? This 15 volt, look, I shouldn't write here 15 volt. This 15 volt will be turned on, and this 15 volt will come here. So 15 volt will come here, this 15 volt will come here. Both have the capability of turning on. This also have the capability of turning on, this also have the capability of turning on. But which will turn on? But which one will turn on first? This one will turn on first, because it has the forward voltage drop of 9 volt and it has a forward voltage drop of 3 volt. You understand what do you mean by forward voltage drop? Potential of P minus potential of N. So it has 3 volt, it has 9 volt. So which will turn on first? The 9 volt bulb. So how will you replace the circuit now? Okay, let's just call this one as D1, D2, D3, D4, D5. So what are confirmed? D1 is on, that is confirmed. D2, D3 is off, that is confirmed. And D4 is on, that is also confirmed. You don't know about D5. Okay, so you will make the circuit and get to know the value of D5. Okay, okay. I don't have a page. I will have to add a page. Now you don't know the condition of this one. So here this is still open circuited. This is still 12 volt. And this is shorted now, right? Shorted and a resistance of 1 kilo ohm is there. I don't need to write the resistance of this resistance. Why so? Because this is open ended, so this won't come in action. This is 6 volt. And here only one diode is on, that is 15 volt. So this is 3 kilo ohm, and here I am having 15 volt, and this is 3 kilo ohm. Now just find the potential of this point. Let's call this point as V dash. What will be V dash? This was 1 kilo ohm, no? At 6 volt, we were having 1 kilo ohm. Yeah. So what is V dash? V dash would be 15 into 1 plus 6 into 3 by 4. 15 plus 18. 15 plus 18 कितने हुए? 33. 33 by 4. So it would be 4, 4, 4, 4, 32. 8 point something it will be. 4, 32, 1, 4, 2, 8, 4, 8.25 volt. Okay, so this potential is 8.25 volt. So here you are having 8.25 volt. And what was the condition of diode? This was the condition of diode. So that means this was your D5. So D5 will be turned off. That means D5 is, so not here, I shouldn't write here, I should only write here. That means your D5 is off. So the value of V dash that you found, that was correct only, 8.25. You found that considering diode to be off only, but you have to find the value of what? Current. You have to find the value of current. This current you have to find. Now tell me what will be the value of current? Current I. Current I. Current I would be 6 minus 15 by 4k. 9 minus 9 by 4k. That means 4 दूनी 8, 1 बच गया, 4 दूनी 8, 4 5 20, minus 2.25 ampere. Right? Since it is 4k, so it will be milliampere. Why the current is negative? Because actually the current is flowing in this direction, right? Current has to flow in this direction, then only this diode will be turned on, and then only this diode will be turned on. But they are asking the current in this direction, so the current in this direction is minus 2.25 milliampere. Let me check the calculations. This is turned on, this is turned on, 15 by 6, that means 9 by 4. 9 by 4 is 2.25 only. Yeah. So minus 2.25 milliampere. In exam, you will solve this problem very quickly. Okay. You will see that only 15 will turn on, and here because of 15, 6 will turn on. So you will solve this problem very quickly. Here I am explaining. That's why this is taking time. Okay. Let's solve this problem. This was a very good problem actually. Okay. Here the concept of network analysis will be used. That's it. Nothing else. So what would you prefer here? I would prefer open circuit test. Okay. So let's apply open circuit test here. So what I will do, I am applying open circuit test. This is 10 volt. Let me grab it a bit down. This is 10 volt here. This is 1 ohm here. Here as well we are having 1 ohm. Here as well we are having 1 ohm. This diode potential we don't know. This is open circuited. This potential is also open circuited. This potential is also open circuited. Here I am having 5 ampere. Now use your knowledge of network analysis and find the value of these potential. This VD2 you will find, VD3 you will find, in this direction you will find, right? VD3, because this is a positive, this is a negative, and VD1 you will find. Okay, use your concept of network analysis and find. What I will do, I would prefer applying superposition. Okay, let's find out the values by applying superposition. So let's first find out VD1. If I consider only 10 volt, what will be VD1? 20 by 3. And if I consider only 5 ampere, what will be VD1? 5 ampere in this branch will go as 5 by 3. Yeah, 5 by 3 into 1. Okay, you can use nodal as well. What I am doing, look, I am first considering only 10 volt source. And what will be VD1? 1 ohm resistance, 1 ohm resistance, both are in series, and 10 voltage across this D1 diode. Okay, this diode. Okay, so what will be that potential? That potential will simply be 2 by 3 into 10, 20 by 3. Now I am considering only 5 ampere current source. So 5 ampere current source is going between in 2 ohm resistance and 1 ohm resistance. So in 2 ohm resistance, 5 by 3 ampere current will be going. And into 1, that will be the voltage drop across it, because 10 volt is shorted. So basically 20 by 3 plus 5 by 3, that means 25 by 3. So I can see diode D1 is turning on. What about diode D2? Okay, because of 10 volt, what I will have? Because of 10 volt, only across 1 ohm resistance. So I will have 10 by 3. And because of this current source, the same current is going in this direction, but the voltage drop is in opposite direction. So I will have minus 5 by 3. Okay, so my potential is 5 by 3. What about VD3? VD3 would be 10 by 3 but in negative value. Why negative? Because this 10 will give voltage drop in this direction, but VD3 I am taking in opposite direction. Okay, right? And what about this 5 milliampere? 5 will be 10 by 3. 10 by 3 voltage drop it will give me, but in negative direction as well. Minus 10 by 3. That means minus 20 by 3. So only two things I know here. This will be on and this will certainly be off. Only I don't know about this, right? Because this has also capability of turning on. VD2 also has the capability of turning on. Diode D2 has also has the capability of turning on. But about D1 and D3 I am sure. D1 is certainly on and D3 is certainly off. I hope I have found the correct values. Let me recheck once. 10 by 3, and because of this here I am having the current. So yeah, that would be 5 by 3 ampere current only, and 1 voltage drop. Yeah, everything is fine, I guess. Yeah. D1, D2 are on, and D1, D3 are, D1 is on, D3 is off. We don't know about VD2. Okay, so now we will make the circuitry. I guess I can copy this only. I will not redraw. I will just copy this on the next page. So this is on. So I will just replace this with short circuit. Okay, and about this I don't know, so still I have to find the potential, and this is off, so this will be open circuited, right? So now I have to find the potential across diode D2. Okay, so VD2 I need to find in this direction only, right? VD2 in this direction only. What will be my VD2 now? Because of 10 volt, how much? 10 by 3. sorry, VD2. Here I am having 0 voltage drop. I just need to find the potential of this point, right? So here what is my V? V by 1 plus V by 1 is equals to 5. Current here is equals to 5 ampere current, right? So V is equals to 2.5. That means my VD2 is minus 2.5 volt. That means diode D2 is off. So what is my final answer? D1 is on, D2 is off, and D3 is off. Got it? Well and good. Easy question. What did we do here? First we replaced this with this model, simple model. We replaced it with this model, open circuit and open circuit. So there we found the value of VD1, VD2 and VD3. VD1 and VD3 values certainly tells that D1 is on and D3 is off. Now thing is about D2. So we made this circuit, we got to know that we are having 0 voltage here and 2.5 voltage here. Okay, and because of this 2.5 voltage, VD2 is minus 2.5, that means diode D2 is off. So this is the final answer. Okay, I have seen many teachers solving this problem by the options, but instead of option, if you go by the concepts, it will be much easier. Those questions which can be solved by the option, I will certainly teach you. Okay, now this you have to find logic level at Z. What do I mean by logic level? That means it can be x plus y, x into y, xy bar by this. Okay, so how do I find the logic level? So I will take the values of x and y. Okay, and then I will find the value of z. Like in 12th class, I guess you remember this thing, logic gates. You can take value of x to be 0, 0, 0, 1, 0, 1, 0, 1. Okay, what does 1 represent here? 1 represents means plus 5, and 0 represents either ground or minus 5. Okay, it will be given in the question. Here it's not given, you can't really comment. Okay, so 1 is plus 5, that is plus VCC, highest plus voltage, and 0 is ground. Now let's assume if this is 0, x is 0, and y is 0. Okay, so these are 0 volt. I am applying open circuit test, 5 volt will come here. This will also turn on, this will also turn on. Are you getting my point? If both turns on, so basically my Z is going to be 0 only. Are you getting my point? What I am doing? I am taking both equals to 0. Okay, both are equals to 0. So what will happen? Open circuited. The condition is S equals to 0 and Y equals to 0. Okay, let's just remove it from here. This is the condition. X equals to 0, Y equals to 0. So here you are having 0 volt. Here also you are having 0 volt. Okay, and this is your plus 5 volt. Now this plus 5 volt will come here. That means this diode D2 will be, this P potential will be at higher potential. So this will turn on and this will also turn on. Is there invalid KVL? No. Because of this 0 volt also you are having 0 volt, and because of this voltage also you are having 0 volt. Z is equals to 0. Okay. Now as X is, now what will happen? Now let's take the second case when X is 0 and Y is 1. Okay. X is 0 and Y is 1. 1 means 1, what does 1 show? Plus 5 volt. Okay. This is 5 volt here. This is the resistance R. Open circuit test we are applying. Here you are having 0 volt and here you are having plus 5 volt, and in this case here you are having plus 5 volt and here you are having plus 5 volt. So tell me which will turn on? This is having a forward voltage drop of 5 volt. That means X will turn on, right? And this is having a forward voltage drop of 0 volt. That means it will turn off. And if X turns on, that means this 0 volt will come here, that will turn it off. If X turns on, that means this 0 will come here and that will turn off this diode. Because here you are having 5 and here you are having 0. Got my point? Just write down the values, you will understand by your own. Okay. So what will happen? This x1 will turn on and this will be off only. So your final output becomes 0 only. In the other case, when y is 1, x is 0, your output will become 0 only. And when both are 1, x and y both are 1, x is equals to 1 and y is equals to 1. Okay, I am applying open circuit test, but I am not open circuiting the diode. Okay, this is plus 5, this is plus 5. If you apply open circuit test, what will happen? Plus 5 will come here, plus 5 will come here. It is having voltage drop of 0. Now you can't tell if it is on or off. Let's say I say it is on. What will be my Z? If I say diodes are on, what will be my Z? Plus 5. If I say my diode are off, what will be my Z? Plus 5 only. So basically my Z will be 1 only. Are you getting my point? In case of 0, 0, what happens? Both turns on. 5, 5, both turns on. Z is equals to 0 only. Okay. In case of 0 and 1, here you are having 5, here you are having 0. Because this is having more forward voltage drop, this will turn on. If this turns on, this 0 will come here. That will turn off this device. 0 here and plus 5 here. So that means this will be turned off. And in case of x equals to 1, y equals to 0, so the same thing will happen. 0 will be at output. And in case of x equals to 1 and y equals to 1, here you are having plus 5. If you apply open circuit test, here also you are having plus 5 and plus 5. Now I can't comment if the diode are on or off. But what if the diode turns on? If the diode turns on, you are having Z equals to 5 only. If the diode turns off, you are having Z equals to plus 5 only. So certainly Z equals to 1 will come. So basically what is Z? Z is x into y. Okay. If you know basic digital circuit, you get to know. If you multiply these two, you will get 1 only. If you multiply x into y, 1 into 0 is 0. 0 into 1 is 0. 0 into 0 is 0. So this is just a AND gate. Okay. So this is the implementation of AND gate. Now you have to find the logic level here. Okay. This circuit have you already seen? In the previous problem only you saw it. The same circuit is there. This diode in this, x is connected to N, y is connected to N. A is connected to N, B is connected to N. So tell me what will be the output here? That will be AB. And what will be the output here? That will be CD. Right? So let's just assume your AB is some x and this is your y and this is your z. So I will take AB equals to x. I will just make that table. And CD equals to y. And my output is Z. Okay. Now let's take the condition 0, 0, 1, 1, 0, 1, 0, 1. If both are 0, this is also 0, this is minus 5. This negative will come. Like here, your logic 0 is minus 5 this time because minus VCC is given. You can say minus VCC, not minus 5, minus VCC. Any supply can be there. It can be 12 as well, it can be 5 as well, it can be 8 as well. And 1 mean plus VCC, this plus VCC. Okay. So now if both are 0, that means both are minus 5. This is minus 5, this is minus 5. By open circuit test, this will be also minus 5, this will be also minus 5. You can't comment if this will be on or off. Let's just assume if both are on. If both are on, what will be your output? Minus 5 only. If both are off, what will be your output? Again minus 5 only. So eventually you are having to have minus 5 only. That means logic 0. Okay. Here this is logic 0. Okay. This is logic 0. This is not voltage. Logic 0 means low voltage and logic 1 means high voltage. Okay. Now this is 0. This is 1. So this is 0 and this is 1. Okay. So that means 0 and 1. That means this is minus VCC and this is plus VCC. Now what will happen? This minus VCC will come here. This minus VCC will come here and this minus VCC will come here. So which one will turn on first? This will turn on. If this turns on, that means this will be, if this turn on, that means here I will have plus VCC. If I am having plus VCC here, that means this will be turned off. So that means what will be my output? My output will be Y. Y is 1 only. So my output will be 1 only. Are you getting my point? So in this case, my output will be 1 only. And similarly, in this case, my output will be 1 only. And when both are 1, this is 1, that means this is VCC and this is VCC. Now what is coming? Here minus VCC is coming. Here minus VCC is coming. That means both will turn on. So basically what they will give at output, they will give 1 only. Right? Plus VCC and minus VCC. That means 2 VCC is here and 2 VCC here. So both will turn on and will give output as 1 only. Right? So what kind of gate is that? Z is equals to output. It's AB plus CD, right? In Boolean algebra, 1 plus 1 is 1, not 2. Okay, 1 plus 1 is 1. 1 plus 0 is 1, 0 plus 1 is 1, 0 plus 0 is 0, 1 plus 1 is also 1. So Y is equals to AB plus CD. That is your answer. Okay, let's move on to the next question. This is the easy question. You need to find the value of V0. Try it on your own. Okay, what do? I consider open circuit test. So here I am having 10 volt. Here I am having 13.3 kilo ohm. I just took this question because I want to check if you guys are able to apply KVL or not. Because guys sometimes don't understand some basic things. Okay. So here this will be 10 volt and this will be minus 5. That means this will be on only. Okay. So diode will be on. That means V gamma will be 0.7. 13.3 kilo ohm. This is 10 volt. Diode is on. That means it will be replaced with the battery of 0.71 kilo ohm. This is your V0. Now write the KVL. This is what I want. Write the KVL. Tell me one thing. If I am saying this is my minus 5 volt, what do I mean by that? That means this is the condition, right? From 0 to here, my potential is minus 5 volt. Are you getting my point? If I am writing minus 5 volt here, that means what? From ground to like this is my 5 volt battery. Or I can say, sorry, this is grounded here. So this is my 5 volt battery because from here to here I am having minus 5 volt. Are you getting my point? Right? And what about 10? If I am saying this is my 10 volt. This is my 10 volt, that is with respect to ground. That you know, right? That is with respect to ground. So what do I mean by that? This is ground and this is my 10 volt. This is 0 and here I will have 10 volt. This potential is giving me 10 volt. This potential is giving me minus 5. This potential is giving me 10 volt. So if I am, so what I can do? I can replace this battery with the 10 volt here. Right? Now I can apply KVL easily. From here I will start. I will just see batteries. Plus 10, minus 0.7, plus 0.5, plus 5. 10 plus, sorry. Only I am seeing batteries. Okay. And I am considering the current is in this direction. Okay. So 10 minus 0.7 plus 5 is equals to 13.3K plus 1, 14.3K into current I. So this is also giving me 14.3K. So the current I is 1 milliampere. The current I is 1 milliampere. That means you are having 1 milliampere current here. That means you are having 1 volt voltage drop here. So minus 5 plus 1. That means your V0 is minus 4. Minus 4 volt. Okay. This is your V0. Well and good. Let's move on to the next question. This is the question. VI characteristics of the diode is shown. You have to find the current I naught. If I find the current in the diode, that same current is flowing from the resistance, right? I can do this question by two analysis. First is the operating point. Find operating point, that will be your V and I. Right? First I write the equation of load line. What is the, I can write the equation of this. This is the characteristics, and one equation I can write, that is load line. So basically, what is the equation of this line? So y is equals to mx plus c. Slope is 1 plus c you don't know. So let's just assume that is 0. That is c. So I am writing the equation of this line. Okay, I is equals to v plus c at I is equals at v equals to 0.7. I is equals to 0. So it has to be minus 0.7. So this is the equation. This is the characteristics equation. This is what? Characteristics equation. Now what is load line? Load line will be tan minus V is equals to 92I. Tan minus V is equals to 92I. Right? This is load line. Okay, this is actually method 1 that we are using here. Then we will use method 2 here. This is method 1. Right? So now I can find the value of, I can put the value of I here. So I can find tan minus V. What do I need to find? I need to find the value of I naught. So instead of V, I will put I plus V is equals to I plus 0.7. I minus 0.7 is equals to 92I. 93I, 9.3 upon 93I. I is equals to 9.3 upon 93. 9.3 upon 93, what it will be? 100 milliampere. Basically, your answer is 100 milliampere. Okay. Or what you can do, by these characteristics, what do you understand? By these characteristics, here you can see that your V gamma is 0.7 volt and your R on is 1 ohm. Right? What is R on? That would be delta V by delta I. This is R on. And what is RD? That is delta V upon delta I. Although both are same in this case. Right? Because if you find the slope at this point, you will get the same slope only. Oh, sorry. So actually you are getting 100 milliampere. That means 0.1 ampere somewhere here. Okay, 100 milliampere and 0.1 volt, and V you are getting is 0.8 volt. So this is your operating point. Here both R on and RD are same. Both are 1 ohm. How did you find delta V by delta I? What is delta V? That is 0.2. And what is delta I? That is also 0.2. So 1 ohm. Okay. So 10 volt battery is there. Then assuming the diode is on, because here we can see 10 volt here and 0 here. So this diode will be on only. And this will be replaced with a 0.7 volt battery. This will be replaced with the 1 ohm resistance. And this will be replaced with a 92 ohm resistance. Okay. This is 1 ohm resistance and this is 0.7 volt battery. What will be the value of I naught now? I naught will simply be 100 milliampere only. Got my point? From circuit analysis also you can understand. You can look. What did we do? We solved some problem in the last lecture, but we did not know what kind of device is that. But here by the characteristics, if we have studied very deeply, we can get to know this is a piecewise linear model of diode. So here we can see that V gamma is 0.7 and R on is 1. So just replace the diode with piecewise linear model. If there is some unknown device, we would solve the problem like this. First we will write the characteristics equation, then we will write the equation of load line, and we get the value of V and I. Here only I needed to find, so I value we get. Okay, but if we already know the device, what is the device? The device is diode, that means V gamma is 0.7, R on is 1. So from there I get the value of I, that is 100 milliampere. Okay, now here as well I know the device. So here again I can replace the device like that and find the value, or what I can do, I can simply solve by the load line. I prefer solving by the load line actually. Okay, I prefer solving by the load line. So let's see the method 1. Okay, what is my load line? What is my characteristics equation? Look, V is going to be greater than 0.7 only. Okay, considering V is greater than, because I will see that diode will be on only. Here I can see the diode is going to be on. So V is obviously going to be greater than 0.7 or equals to 0.7. So my I is this only. I am not considering this case. If I solve the value of V and get the value less than 0.7, then I will see this case. Okay. So method 1, this I am applying. What do I consider? Considering V is already greater than 0.7, this I am considering. So this is what? This is what? This is characteristics equation, right? This is characteristics equation. Characteristics equation. Okay. And what is my load line? That is tan minus V is equals to 1000 I, because this is 1 kilo. So tan minus V is equals to 1000 I. Okay. So this is my equation 1 and this is my equation 2. So what do I need to find? I need to find the value of I only. I can replace my V with I. That would be tan minus 500 I plus 0.7. So it will be 500 I plus 0.7. That means minus 500 I minus 0.7. That is equals to 1000 I. Okay. So from here 9.3 by 1500. That is the value of I am getting. So from here I will get is 9.3 by 1500 into 1000 I can do. So 6.2 milliampere I am getting. Okay. 6.2 milliampere I am getting. This is the method 1. And what can be the method 2? If you are smart enough to understand here. Okay, I is given 6.2 milliampere. Now you have to find the value of V as well. What value of V you are getting? 6.2. So I know, wait a second. Yeah. What is the value of V you are getting? 6.2. So 10 minus 6.2. 10 minus 6.2. Here if you put in this equation if you put, so that is 3.8. 3.8 volt. Okay. This is the value of V you are getting, which is greater than 0.7 only. So your initial assumption is correct. Okay. Now people will get a doubt that V has to be 0.7. Now you will say that V has to be 0.7 because if the diode turns on, I can see that cut-in voltage is 0.7 volt here. So it has to be 0.7. Is it so? What is V? V is this. Okay. Here, this is your cut-in voltage. What is R on? Look, you know one thing. ID, if this is how you replace it, right? This is R on. And this is your V gamma. And this is VD. And this current is ID. So VD minus V gamma is equals to ID RD. So here you can see that ID is equals to VD minus V gamma upon RD. Now relate it with this equation. This is the equation given, and the equation that is given to you, that is I equals to V minus 0.7 by 500. So what did you understand? What is the value of V gamma here? That is 0.7 volt. And what is R on? That is 500. Okay. This is 10 volt, 1 kilo ohm, this is 500 and this battery is 0.7. Now you can find the current. The current value that you will get is 6.2 milliampere. So by the diode model also you can verify. By diode model you can see that your cut-in voltage is 0.7, RD is 500 ohm. So from here you get the value of current, that is 6.2 milliampere. Well and good, easy question. I prefer this method because without even knowing the device, irrespective of any device, you can get the value of operating point, right? We have solved very good problems on this question, on these type of question, finding operating point. So these are very easy question. Okay. Now this is the question that was asked in GATE examination, and I have seen many teachers solving it wrong. Okay, I will not take anyone's name. Both all are respected teachers. They have done really good in their life, but this question I have seen many teachers solving wrong. I don't know why. They solve it by large signal analysis, DC analysis, but here it is mentioned minimum to maximum small signal voltage gain. Okay, let's read the question. A current and the characteristics of diode D is shown. This is the DC characteristic of the diode is shown. Okay, the ratio of the minimum to maximum small signal voltage gain. Okay, small signal voltage gain, that means this diode will be replaced with its RD. Now what is the minimum value of RD? I told you one thing. Okay, this will be replaced with RD. What is RD? RD is neta Vt upon IDC, right? This is your RD. What can be the minimum value of RD, IDC? When IDC is equals to 0, that means RD will be infinity, right? That means diode is open circuited. And when IDC is equals to infinity, look, after 0.7 IDC can take any value. It can take 10 milliampere, 20 milliampere, 30 milliampere, 50 milliampere. It can take infinite milliampere as well, right? After what did I say? When Vd is equals to 0.7 volt, ID can take any value. Since there is no input signal mentioned, Vin is not mentioned, you don't know what can be the value of In. So basically ID can be infinity. So your RD will be 0. So you have two conditions, RD equals to 0 and RD equals to infinity, right? When RD is equals to 0, what will be your V out by Vin? When RD is equals to 0. When RD is equals to 0, what will be your V out by Vin? Tell me. Del V out by Vin you can say, or V out by Vin you can say. RD is equals to 0. This will be shorted. So simply it will be 1 by 2. Right? And when RD is equals to infinity, what will be your V out by Vin? That will be 4 by 6. That means 2 by 3. If this is infinity, this will be open circuited. So 2 plus 2, 4 by 6. That means 2 by 3. So what is the maximum gain? That is 2 by 3. What is the minimum gain? 1 by 2. What did they ask? Minimum to maximum. So from here, what will be your answer? Minimum to maximum ratio. What is minimum? 1 by 2. And what is maximum? That is 2 by 3. So answer would be 3 by 4, 0.75. This is the ratio. Okay. So this is your final answer. What is the ratio? Ratio is 0.75. Minimum to maximum. Okay. In these kind of question, you should always see from what ratio to what ratio they are asking. Minimum to maximum, that means minimum upside and maximum lower side. Okay. So minimum is 1 by 2 and maximum is 2 by 3. 1 by 2 divided by 2 by 3. So basically 3 by 4, that means 0.75. Okay. Got this problem? What did you need to find? Minimum to maximum ratio. Okay. Then you see that diode can be replaced with its DC equivalent, because we are talking about small signal voltage gain. Okay. So how DC equivalent would look like? DC resistance, sorry, AC equivalent, AC equivalent. So what is the dynamic resistance? That is neta Vt upon IDC. When IDC is 0, your RD will be infinity. When IDC is infinity, your RD will be 0. When RD is 0, that means your V out by V in is 1 by 2. And when RD is infinity, that means your V out by V in is 4 by 6. That means 2 by 3. Minimum ratio you are getting is 1 by 2. Sorry, minimum gain you are getting is 1 by 2 and maximum gain you are getting is 2 by 3. So 1 by 2 by 2 by 3. That means 0.75. Well and good. Let's move on to the next problem. I also want you to solve this problem on your own. First, you need to find the DC current. Okay. There are two voltage, DC voltage and AC voltage. First, you need to find the DC current. Since there is 12.7 voltage and 4 diodes are there, what will happen to diode? Diodes will certainly turn on, right? Diodes will be certainly turned on and all have the cut-in voltage of 0.7 or forward bias voltage drop of 0.7. So this will give you 0.7, this will give you 0.7, this will give you 0.7, this will give you 0.7 in this direction, in this direction, in this direction, in this direction. So here it will be 2.8 volt, right? So what will be your IDC? This will be your IDC. So simply, what will be the answer of first one? IDC would be 12.7 minus 2.8, that 12.7 minus 2.8 divide by 9900. 9.9 by 9900. That means 1 milliampere. Okay. Now tell me what will be your RD? Neta VT upon IDC. What is the value of neta? Have they given it? Did they say it is silicon? They did not say it is silicon. Okay. Did they give the value of neta? No. So I have to consider neta equals to 1. Did they give the value of VT? Yes, they gave the value of VT, that is 25. Neta I have to consider 1 because nothing is given. If they had given silicon, I would take 2. They gave nothing. They didn't talk about neta. So I will take 1. 20 milli upon 1 milli. So basically it will be 25 ohm. So every diode will be replaced with 25 ohm resistance. Every diode, right? This diode will be 25, 25, 25, 25. So what will be my AC model? I have the AC signal here. Okay. AC signal which is V in. Then I have this resistance, that is 9900 ohm. Then 4 resistors are there, RD, RD, RD and RD. These 4 resistors are there. All are 25 ohm, 25 ohm and 25 ohm. Total 100 ohm resistance is there and I need to find the equivalent VAC. This is my VAC. What is my VAC? That is 100 by 1000 into V in. That will be V in by 100. That is my VAC. So basically, my VP input was, VP cos omega t, that 100 millivolt cos omega t. So 100 millivolt by 100, that means 1 millivolt cos omega t I am getting. Okay, so this is my VAC. 1 millivolt cos omega t. Okay, this is my VAC. Okay, what did I do? First I found the DC current. From there I got the value of RD, that is 25 ohm. So all diode will be replaced with 25 ohm resistance. So total 100 ohm is there, 100 by 10,000. That means the gain is 1 by 100. So basically my output will be 1 millivolt cos omega t. Now this is a very good question, and you can say this is a surprising question as well, because here they have talked about the capacitance, junction capacitance. Okay, so there are two biasing in diode, there are two biasing, right? I will just give a brief concept. Okay, you don't need to go deeper into the concept. Okay, so there are two biasing, forward and reverse. Okay, in forward bias there will be diffusion capacitance, and in reverse bias there will be transition capacitance. How does this capacitance come? You don't need to think about it. Okay, this is completely diode physics. EDC guy will study it. Okay, the guys who have EC branch and those guys who are going to study electronic devices, they will study it. Now you don't need to push yourself from where this diffusion capacitance is coming, from where this transition capacitance is coming, what is the formula of that. You don't need to push yourself. Okay, and this diffusion capacitance is sometimes called junction capacitance as well. Okay, here it is given junction capacitance as well. Actually, you also don't need to remember which one is called junction, which one is called transition. Okay, so basically if diode is having this junction capacitance, so how you will show it junction or transition, whatever the capacitance it is having, how will you show it in circuit diagram? You will just show in the parallel here. Okay, so the C junction will be replaced in parallel. That's it. And during DC analysis, it won't come. During AC analysis, it will come at a certain frequency. Okay, so during AC analysis, it will come. Okay, deeper concept of this I will give in EDC, not here. In electronic devices, we will see much deeper concept of this. Okay, this is the junction capacitor. RD in parallel with CJ. Well and good. So how can you remember it? Look, forward D, FD, forward bias diffusion capacitor, FD. You have heard the term na, FD. Invest करते हो कि नहीं करते हो? You must have invested in FD, right? And RT, retweet. Are you guys using Twitter? Not Twitter, sorry, X. Are you guys using X software? Not software. What is happening with me? X application. Are you guys using X application? So in X application, there is a term RT, retweet. Okay. So this is how you can remember. RT, reverse transition. FD, forward diffusion. Okay. Yeah. So this is how you will replace it. Let's read the question now. A DC current of 26 microampere is flowing. This is already given. This is given here. 26 microampere current. The diode is in forward bias. It has ideality factor of 1. Ideality factor or non-ideality factor, whatever we get. Neta is 1. At Q point, that means at operating point, the diode has a junction capacitance of 0.5 nanofarad. Its neutral region resistance can be neglected. Okay. Assume that the room temperature thermal equivalent voltage, that means VT they are talking about, 26 millivolt. It's neutral region resistance. That means they are talking about R on. Okay, R on is 0. They are saying R on is 0. Okay, neutral region resistance. This is what they are talking about, or neutral resistance. Yeah, they are talking about R on only. I think what do they mean is that in PN junction they are talking about the depletion region resistance. Okay, they are talking about the depletion region resistance, I guess. This they are talking about R on only. But if we don't know, let's forget it. As far as I know, they are talking about R on only. Okay, neutral region resistance. Neutral region resistance. Yeah, it can be R on only. Okay, so R on is 0, but it can be neglected, so we won't think about it. Okay, for omega equals to 2 into 10 to the power 6 radian per second, the amplitude of small signal component of diode current. So you just need small signal analysis. Okay, so in small signal analysis, what is your IDC that you already know? So RD you can find, right? In the next page I will write RD. I can find now. What will be my RD? RD will be neta VT upon IDC. VT is my 26 millivolt. IDC is my 26 microampere. My RD is 1000 ohm or 1 kiloampere. My C junction is given, that is C junction is 0.5 nanofarad. What will be my equivalent circuit? Current value I need to find 5 sin omega t. Amplitude only I need to find, and small signal. So forget about DC. Okay, DC will not come, only small signal. 5 sin omega t millivolt. This is the 5 sin omega t millivolt, and diode is replaced with its RD, that is 1 kilo ohm, and in parallel to that this CJ will also come, right? This CJ will also come, and then you are having this resistance. This resistance is 100 ohm. Okay, and your input is 5 sin omega t millivolt. What will be the current? Current IAC you can say. What will be the current? voltage upon total resistance. Now you have to find that resistance provided by this capacitance, that is ZC, that is minus J by omega C. That means minus J by omega is 2 into 10 to the power 6 into 0.5 into 10 to the power minus 9. So it will be 1000 ohm. So this is ZC. Now this parallel with this. So basically this is providing you how much impedance? Minus J 1000, right? Minus J 1000. Now minus J 1000 in parallel to 1 kilo ohm. So basically ZC is parallel to 1 kilo ohm. That means minus J into 1 kilo ohm into 1 kilo ohm upon minus J upon minus J 1 kilo ohm plus J 1 kilo ohm. Okay, so it will be minus J into 1 kilo ohm. 1 kilo ohm will come outside, it will be minus J plus 1, right? So this is the impedance provided by this parallel combination. Am I doing the calculation right? Let me check. Minus J 1 kilo ohm into 1 kilo ohm upon J. 1 kilo ohm will come outside. Minus J into 1 kilo ohm will be there upon minus J plus 1. Okay. So what will be my total resistance? Now what will be my current now? IAC would be 5 millivolt cos omega t upon 0.1. If I take minus minus outside, so it would be J 1 kilo ohm upon J minus 1 into sine omega t milliwatt, right? This is turning out to be a tough calculation. Can I make it easy anyhow? Let's just solve it. 0.1 1k with 1. Okay, let's just solve it. Yeah, so the calculation is going right only. Just I wrote 0.1 here. This is 100 ohm. So why would I write 0.1 here? If I am writing 0.1, it should be 0.1k, right? Now what I can do, you can solve it on your own, or I can solve it as well. This is just an AC quantity, so it is taking me time. Okay, I am not that good with AC. Till gate level I know. Okay, now people will say I am not good at gate level as well. Till gate level I know, but AC is mainly these electrical guy deals AC very well, right? Because we deal in DC, right? Now this J minus 1 is going upward. J minus 1 is going upward because ETC guys are mainly focused toward DC. We won't go over 12 volt. 12 volt is the max. When you work in industry, you will never go above 12 volt if you are working in electronics industry. 0.8, 0.7 MOSFETs and all these things will not go above 0.8, 0.2, 1.2, 2 volt. But this AC 220, right? 220 volt RMS. Yeah, so this J minus 1 is going upward, and this 100J 1, it will come 100J minus 100 plus J 1000 into sine omega t millivolt. Okay, so it will be 5 millivolt into J minus 1 upon 1100 J minus 100 into sine omega t millivolt. Now you can find the magnitude, right? 5. Oh, here I am writing millivolt, so I don't need to write millivolt here. What will be the magnitude of this? Root 2. 5 into root 2 upon what will be the magnitude of this? 1000 whole square plus 100 whole square into sine omega t, and millivolt is here. If you solve this, you will get 6.4 micro ampere sine omega t. This is your IAC. Calculation part was a bit complex. Okay, so if these kind of question come, you should be patient there. Okay, you should solve these question with patience. So the current amplitude you are getting is 6.4 microampere. So in microampere they asked, so your answer would have been 6.4. Okay, so diode is replaced with dynamic resistance and a capacitance in parallel. The value of capacitance is given. Okay, now ZC, from there I can calculate the impedance provided by the capacitance, that is 1000 minus J 1000 ohm, and from there I found the value of current. Those were in parallel, so I found the value of parallel resistance, and then just IAC, voltage by total resistance, voltage by 5 millivolt sin omega t. Okay, 5 millivolt sin omega t, and total resistance was 100 plus this resistance. Okay, so from there I solved it and get the final value. So this is the complete question, complete analysis, everything on simple model of diode. Then we studied operating point, then we studied the small signal analysis, that means AC analysis of diode. So everything we have studied. Now the time is to study clipper circuits. So now we will be studying clipper circuit. Okay, so I hope you are liking the lectures. I hope you find it good. So please do like the lecture and do share it with your friends. Okay, it will motivate us to bring more content, right? Thank you.